Welcome to our review on useful energy and efficiency. First thing we need to understand are three key terms. So we've got useful energy first of all, which is the energy that we're going to be using for a designated purpose, and that will be revealed in the question. We've got wasted energy, which is the other forms of energy that we're generating that are not being used for that same purpose. And then finally, the efficiency is the percentage of energy that's being transferred by a device into the useful energy. So it's basically looking to see how much of the energy are we actually getting for the job we want to do. One way we can show this is through the use of something called a Sankey diagram. So quite simply, it's an arrow that shows the different forms of energy and what they're then changed into. So what we need to remember is if we're asked to draw a Sankey diagram on the exam paper, then the width of the arrow represents the amount of energy. So do make sure you remember that fact, that if you're asked to draw one, make sure the width is representative of the energy. So use a scale. So what we can see in the diagram at the bottom there is we're starting off with 1,500 joules of electrical energy in our light bulb, and that's going to be converted into 300 joules of light energy and 1,200 joules of energy being changed to heat. So what we find there is that the useful energy, because it's a light bulb, is the light energy. The wasted energy is going to be the heat. To calculate the efficiency then, all we need to do is the useful energy output divided by the total energy input times 100. And again, you don't have to memorize the equation because that one is on page 2 of your exam booklet. So if ever you're asked to calculate the efficiency of something, flick back to page 2, find our efficiency calculation, and then substitute in the numbers. So I've given you the example here. So what's the efficiency of the light bulb shown in the diagram? Our useful energy, because it's a light bulb, will be the light energy, which is 300 joules. And we've got 1,500 joules of the total energy supplied. So all we do there is useful divided by total, so 300 divided by 1,500, and then to get it as a percentage, times it by 100. So it would be 0.2 times 100 gives us 20% efficiency. So what we can see is, in reality, the light bulb is not very efficient.